What have been the prevailing scientific theories of the origin of the universe?
In this century, as we've begun to learn a little bit more about galaxies moving apart from one another, and we've begun to learn a little bit more about the energy sources in stars and how stars produce their energy and that sort of thing, we've had a sifting down, if you like, of available cosmological models. A century ago, a century and a half ago, an atheist might very well have felt that the universe has always been here and stars perhaps have always burned, and yeah, we don't know how a star could keep going infinitely, but we don't know how stars keep going anyway, so no big deal. But with the discoveries of the nuclear processes, with the discovery of the expansion of the universe by Hubble, and actually a little earlier by his predecessor, it's become apparent that you're in an expanding universe that is running down in the sense that it's using up the hydrogen fuel and such available. The upshot of that was, by the end of World War II, two basic kind of models had arisen in scientific circles for cosmology. One of them was a model that the universe came into existence in some sense at a finite time in the past and has been expanding from that, a Big Bang model. And perhaps we should say a little something later about varieties under that. And the other model was, no, the universe has always existed, but matter is popping into existence continually at a finite rate, what's called the steady state theory of the universe. And those have been kind of the two big models from the late 1940s up until the mid-60s and perhaps even into the early 70s. The story of how they seem changed is a rather interesting one.
How did the shift from a steady state model of the universe to the Big Bang model take place?
The story of the shift from a competition between steady state cosmology and Big Bang cosmology is rather interesting. In the late 40s and early 50s, when the steady state was first proposed by Hermann Bondi and Fred Hoyle and Thomas Gold, they really claimed their position was philosophically and scientifically much superior to the Big Bang, because the Big Bang proposed a cosmological principles. Things look the same in all directions over large areas of the universe. But they proposed the perfect cosmological principle, that things not only look the same in all directions, but they look the same at all times in the history of the universe. That in their model of the universe always had about the same density over large volumes. It always had a certain number of dying stars and a certain number of new stars and a certain number of new galaxies and old galaxies and that sort of thing. And they said, you know, this is really the scientific feature of methodological atheism or methodological naturalism spread out, you know, carried to full degree. And I think a number of people bought into that. However, a problem developed fairly early on, and that is, as they began to try and look further and further into the universe, researchers were trying to find out whether we lived in a universe that looked like it was getting thinner, less dense now than had been earlier, or whether the density looked like it stayed the same at all times in history, because the Big Bang predicted a hot, dense universe that was becoming thinner and cooler as it went on, whereas the steady state predicted a universe that was staying the same density and temperature on large volumes everywhere. Well, the first thing they did was they began to try and make counts of galaxies per unit volume, and it looked like there were more galaxies per unit volume at great distances than there are nearby, and that was assumed then to be earlier in its history than currently, and that favored a Big Bang type universe. Steady state proponents could basically say, well, there may be all sorts of features regarding the aging of galaxies or even regarding the absorption of starlight and things of that sort that may affect that, so it's hard to really be sure about that. But then quasars were discovered early in the 60s. Quasars, we're not sure what they are, although the general guess now is they are very unusual centers of early types of galaxies. These things can be seen at enormous distances. Some of these quasars appear to be visible as much as perhaps 10 billion light years away. They hadn't seen any that far away in the early 60s, but they were certainly looking at what we might call cosmological distances. Distances that the light traveling would be traveling a substantial fraction of the history of the universe if it were a Big Bang universe, and a substantial fraction of the lifetime of stars, even in a steady state universe. And what they began to see immediately was there were lots more quasars way back in the past than there are now. as best you can tell. Realize in cosmology you can't tell the difference between distance and time because we can't wait around billions of years. So distant objects you're seeing from way back in the past and such. So that's began to become apparent. And that began to put a stress on the steady state theories of the universe. And perhaps the last nail in the coffin or something of that sort was this discovery by Penzias and Wilson that all the sky in the radio frequency wavelengths was glowing at night. And the glow was the same in all directions, and therefore was a cosmological glow, not a glow from our galaxy or a glow from our solar system or a glow from something else. It was something that was the same in all directions. And that, of course, has panned out very nicely in recent years now with the COBE satellites and such, seeing a very, very good fit of this black body radiation, of this cosmic radiation, as fitting a temperature of just under 3 degrees absolute. What that showed, I think, is that the models of the Big Bang, which had already predicted that there would have been some point after the Big Bang, a time when the universe became transparent, and they estimated what the temperature would be at some 3,000 degrees, and that by now that would have dropped down order of 5, 3 something degrees absolute. And here it was. A prediction made by Gamow, one of the Big Bang men, was panned out in the research. And so that really was kind of the last straw, so to speak. Fred Hoyle held on to his steady state theory for a few more years. He seems to have gone out of it now, but that really was the end of that. We have a universe which had some kind of a beginning at the Big Bang.